So I'm going to make up some questions as if I was the examiner. So the first thing in straight line functions is it's in paper 1 and paper 2. And if I said to you, I wanted you to draw for me the graph of a half x plus a third, and in fact, I'm going to call that the function f. And I also want you to draw the graph of g, which is that function. Now, okay, let's start with that. I want everyone to draw and do the working out for these two functions, f and g. And once you have drawn your graph, I want you to say done in the chat. And then I'm going to make some questions about these two functions. And I'm going to start remixing. So while we are, students are still joining us, I see a Bongway is waiting in the waiting room. Let's have a look. So we have to, the first instruction is to draw these two graphs on the same Cartesian plane. And I want to see if you can do that. Okay, so what I get for the function f is my y-intercept is 0 to third, and my x-intercept is that. You can let me know in the chat whether you agree or not. And then you still need to draw these graphs. Then I'm going to ask you some questions about them. Oh, have I made a mistake? My green graph looks suspiciously wrong, doesn't it? Because, let's bring that back. What is wrong with my green graph? Why does it, no, it's right. 0 to 3rd, sorry, 0 to 3rd is there, and minus 2/3, I lie, I was correct. The question about how is it -6 and not 6, I will look at that now for Tejo. For Tejo, when you bring the 2 across, oh, it should be +6. Yep. So it's the red one which is wrong. Oh, goodness gracious me. You're quite right. So this should be on that side, and this should be +6 because 2 negatives. So that would be, the graph should look like, let me draw it in here. Well spotted, Fatejo. That was a good spot. Okay, so that should be a 2. And then what was this one? This one was -2/3. And then this one was a 3rd. Okie dokie. And I've got to label it. So what are the labels going to be? The one going through 2 is going to be labeled G, and the one labeled with the green is going to be F. Okay. Thumbs up if you could do that. Thumbs down if you couldn't. Yeah, I see there's a student in the waiting room, just to check that. There's 2 students. Oh, quite a few students. We have a quick look there. Okay, now, next part. I want you to find me this point where the 2 lines meet. We call that the intersection point. What is that point going to be? What is this point over here where the 2 lines meet each other? What's that going to be? Maybe you can even give us a tip as to how. So if you look at the graphs, it's where they cut for Tejo. So you need to do what? You need to equate or solve them simultaneously. So you need to say, well, I need to know the X value where that statement is true. And so you need to figure out for me how to solve that equation. Yeah, Trishan, you're on the right track. So let's see if you can find me that value of X. I'm hoping it's going to be a positive value. Otherwise, my drawing is very wrong. I'm not using my calculator, but you could use your calculator for this. So we get, you don't have to do it like I'm doing it. I'm just doing it the old-fashioned way. I don't get 2. I get, so if I times this side by 6 and 5, I'm going to get, oh, that can't be right. How can it be a negative? Unless the thing is way out. Let's have a look. Have I made a little mistake along the way? So minus comes across, it becomes a plus. 3 out of 6, 2 out of 6 is fine. 2 minus 3 is minus 1. It's not a third. Oh, it's a third, not 3. Yes, okay. So that's where the mistake was. I wrote the question down. But can you see how the math never lies? Like you can see how the math was telling me something that just wasn't true there. So we go a half x plus a third x is 2 minus a third. Okay, and now we're in the right part of town. So if I make the half 3 over 6, I make this 2 over 6, and then I could make this 1 and 2/3. I would recommend using your calculators. You don't have to do it like this, but it is helpful if you don't have one. And then if I multiply both sides by 6 over 5, that will cancel, and x would be 5 times 6, 30 over 15, which is 2. So I get that x is 2. Give me a thumbs up or a smiley face if you also got that value. X is 2. You can see the big blue dot with the 2 there. Okay, now I want to know what is the y value that goes with the x2. So you've got the x coordinate of the intersection point, but now I want the y value. How are we going to find a y value? Yep, we just substitute in. And I chose the one without a negative fraction. So a half times 2 is 1, and 1 plus a third is 1 and 1/3, or you could also say 4 over 3. And so I'm going to write that as 4 over 3. So that is what the intersection point is. Okay, now I'm going to mix in another topic. So we are going to call 3 points on the drawing A, B, and C. So I'm going to zoom in a little bit so we get more of a focus on just that drawing. And I'm going to call this point that you just found A. I'm going to choose this point down here, the x-intercept, as B. And I'm going to choose this point over here as C. I want you to find me the perimeter of triangle ABC. Who can tell me what tools I need to use to find the perimeter of triangle ABC? A Bongwe, you do indeed need to find the distance formula, and you need to find for me AB, BC, and AC in order to find the perimeter. So I want you to go ahead and do that. See if you can find what the perimeter of the triangle that I've made is going to be. If we want to make life easier, we can actually write down the coordinates of the points. So if we think of A, well, we know A is just 2 and 4 over 3, so that's already been done. B's point is minus 2 over 3, 0. And C's point is 6, 0. So that just helps us make sure we're doing the right thing. Because of the fact that these are both on the x-intercept, this distance is actually quite easy because it's just going to be 6 2/3 because it's on that straight line. But finding out what A, B, and AC are is going to require a bit more working with your calculators. And so I want to see what you get. So for AB, yeah, you're going to go 2 minus 2/3, so 2 2/3. And then you go 4 over 3 minus 0. So that would be 4 over 3. But then you have to go through and get the messy stuff. And then what about AC? 2 minus 6 would be minus 4. And 4 over 3 minus 0 is just going to be 4 over 3 again. So what is my final perimeter going to be? That's what we're waiting for. If there's something I've done now where I've lost you, please do ask, because there's definitely going to be distance formula type questions mixed in with straight lines in paper 2. They love this. This is a very common type of question. We get it here. Square root. So I get some decimals here. I get 4.22 for that one. Where did I get 2 2/3? So if you look at the point A, are you happy that the point A is 2 and 4 over 3? And then B is minus 2/3 naught, because we've already got that written in. And this one was 6 naught. So when I went 2, so for AB, I went 2 minus 2 and 2/3, which becomes a 2 plus 2 and 2/3. And then I went 4 over 3 minus 0. Well, that's just going to give me 4 over 3. So I was just doing that. And then for AC, I just went 2 minus 6, which gives me minus 4, and 4 over 3 minus 0, which gave me 4 over 3. This is in paper 2, Trishan. Yeah, so the distance formula stuff is in paper 2. We're not doing the grade. I haven't done grade 12 stuff tonight because there's still many of you haven't written paper 2. And so I'm staying with grade 11 stuff. Just I'm sort of making it interesting and mixing things together like you would in an exam. Let's see what we get for AB. So put your answer for AB in the chat. I'm going to work it out. So I'm going to put a mixed number, 2 and 2/3. And then that has to be squared plus 4 over 3 squared. And then that all needs to be square rooted. And I get 2.98. So my three values. Now, what I want to know in the chat is if you got the same thing for each of these, put A, B, B, C, A, C, showing me the ones you had the same, or how do I say this? No, actually, I just want to know, did you get that, or do you understand how I got that? And what do I still need to do to get my answer? Okay. So you still need to find the final answer now. So if I take the rounded off values, you should be getting something around 13.86, or let's say to one decimal place, 13.9 units. If you add up these three sides. Okay, now before we move on to a second type of question, I want to bring in a little bit of something called the angle of inclination. Who can put their hand up and tell me what is the angle of inclination? When I talk about straight lines, what's the angle of inclination? Who can remember what the angle of inclination is? So I'm monitoring the chat, but I'm not seeing any things, any hands going up. Okay, I'm going to get rid of the stuff here. So the angle of inclination of a straight line is, Kevin has said the angle of inclination, the gradient. Okay, I'm on the right track. So the angle of inclination is the angle that the straight line makes with the x-axis. And the formula that we use to help us is the tan of theta equals m, where m is the gradient. Now, I want us to look at our drawing over here, and you'll notice that I've written in the equations of each of these to help you. I want to know what is the angle of inclination of the green line. What is this angle of this over here? Can you work out what the angle of inclination of the green line is? And I've tried to show it to you a little bit there by, maybe I can zoom in a bit more. Work it out for me. Tell me what the angle of inclination is for that, using that formula. So you have to identify what the gradient is. And the gradient of the green line was a half. So now you need to tell me, what angle do you think the angle of inclination is going to be? Well, I go shift tan or inverse tan a half. And what do I get in my calculator? I should be getting 26.57 degrees. So this red dot angle here is 26.57 degrees, which makes sense if I look at the rough drawing. Okay, so I will come back to this after the break, but we've been going for a solid half an hour, and I know that we all need to stand up and stretch. So I want you to turn your cameras on. I want you to So Patejo, I'm going to come back to that after the break. I promise I'm not moving on. We're going to do more of that after the break. But for now, our main priority is just to get some circulation and oxygen back into our bodies. So let's start with some breathing. So stand up and get nice and relaxed, and let's start with some breathing. So okay, one more deep breath. So I can definitely feel how I have more oxygen in my body now. So I hope you are having the same experience. So let's shake our arms a little bit just to get some circulation. So you want the blood moving in your body. Probably gone to sleep if you were sitting for too long. I want you to shake your legs. Make them nice and big too, so you can get the blood pumping. And let's start with the tricep stretch. Looking out in front of you, just holding it like this. And then switch to the other arm. Okay, and then once you've had a stretch, just shake up the arms again. And shake up the legs. Okay, next bit, have arms out. And just gently rotate from hips. And, as you relax, see how much further you can. Well, not too far. You don't have to reach it off. Yeah. Okay. Then let's get our arms out. Let's have some small circles. Going round and round, and then some big circles. And then let's put this across here. Stretch. And then let's go to the other side. Let's hold it for a bit. Oh, there we go. I can feel my body is waking up. Okay, now, really to get things moving, what we need some proper movement. And we can do, I think we need to do, okay, let's not go crazy. Let's do some air skipping. Okay, we're going to do 20 in 3, 2, 1. Let's go. And that is the exercise portion of the lesson done. I hope your body feels somewhat awoken. Let me know in the chat. I know it's not everyone's cup of tea, but I can't deny the fact that I feel much more, my brain feels much happier to engage with maths once I've done that. So let me know in the chat. Are you someone who enjoys it, or are you someone who's like, this is something that I have to do because I'm here, or maybe you don't do it. But let me know in the chat. And then while you are doing that, let's have a crack at these Maths 24 questions. Okay, Emmanuel, 8 minus 2 times 6 minus 2. The red one has fallen to Emmanuel. Well done. What about blue and yellow? That's a 6, in case you're unsure, that's a 6. I think the 6 minus 2 trick could be helpful. Okay, I think I haven't seen more answers, so I'll give you 15 more seconds, and then I'm going to give you the answer for this one, and then we're going to go back to our class, or our lesson. So I think someone would have got this, but 6 minus 2 is 4. It's not plus. It would be 4 times 6. So 6 and 2, 2 and 3, and then we get our 24. Okay, I hope you enjoyed the maths 24. Okay, so back to this yeah. So what I want to do next, and it's a slightly different type of question, is I want you to find the angle of inclination now of the red graph. So the red one has the equation minus a third x plus 2. And so I want you, not the equation, sorry, the angle of inclination. So I want you to work out what is the angle of inclination of this red straight line. And then for Teco, the way it worked when I was dealing with the green one is I subbed in, I looked and found the gradient of the green line, and I put it into my formula. And then I said shift tan a half, and I got this angle. Or I got, yeah, so inverse tan of a half, and that gives me this angle over here. Now, there is a little bit of a difference with the second one, but I'm going to see what you remember from class, and then we'll get going. See what you can. What is the gradient, not the gradient, the angle of inclination going to be of this? I'll put it like a green dot there. So the red one, M is negative. You're absolutely correct. And that is the sneakiness. There's actually 2 methods. Different teachers teach it different ways. I'll show you both methods. But if we say the tan of theta, or the tan of the green dot, is equal to minus a third, that is a fantastic start. But now there are 2 ways we can do this. The one is where we ignore the negative. The other one is where we include it, but we make an adjustment. So I'll call method 1 the ignoring method, and I'll call method 2 the adjustment method. Both of them will give us the same answer, but there are different ways to get there. But I want you to try and get your answer first before I start telling you what to do. So for the ignoring people, you first have to decide where tan is negative, and tan is negative in quadrant 2. And so you know all angles in quadrant 2 are 180 minus your reference angle. So you know your answer will be in quadrant 2, but when you solve a trig equation and you know what quadrants it's in, you will just ignore the negative, and your reference angle will be something, and then you'll go 180 minus the reference angle. So if I put, and I must make sure I don't, yeah, so shift tan 1/3, I get 18.43, but that is not the correct answer. It's way, way too small. And the reason is the answer is not in quadrant 1, it's in quadrant 2. And so theta Okay. The actual theta will be 180 minus 18.43. So, and that would be 161.57. Or if you use the adjustment method, you would just leave the minus a third there. Minus a third equals tan theta, no problems. And then what you do is you go shift tan of minus a third. And what do we get? Shift tan minus a third. We get minus 18.43. Now, what has happened when you use the adjustment method is it's actually found the angle down here, the angle going from the positive x-axis in the clockwise direction. And to get to this one, we need to add 180. So the real angle that we're after, we just have to add 180. And that gets us to the angle on the other side of the line. So if it's here now, get that, and then you'll get 161.57. And what I wanted to show you was that when you're finding the angle of inclination with a straight line, it does make a difference whether it's negative or positive. Okay. Thumbs up if you followed me with that bit. Thumbs down if you didn't. All right. Now, I want you to work out for me the angle. Let's make this O. I want you to find me the angle OAC. So OAC is going to be it's going to be this one over here. Can you find me that angle up there? Now you have to use a couple of different sections to help you. Not a couple, but have I rubbed it out? Oh, I've rubbed out the earlier answer. Flip. Okay. It's going to be hard to see it from then. I'm just going to show you then. Earlier on in the question, so we just worked out now that this was 161.57. Earlier on in the question, we worked out what that one was there, and I think it was 26.57. Can anyone remember? What was the angle that we worked out over here? 26.57. Okay. Now, I'll even get rid of this little bit here. So this angle is 26.57. What relationship is there between this angle over here and these two angles over here? Or maybe I should say, actually, let me get rid of the green here. So I'll put 26.57. What do we need to do to figure out what this angle over here is? We could actually work out what this one is here. This was 18.43 because of angles on a straight line. How am I going to get this one up here? What's it going to be? So I know that was 26.57. I know that's 18.43. What's the yellow one going to be? And what fact am I using? Indeed, Fruti, it is the exterior angle of this triangle. And so in order to find it, what is my answer going to be for this angle? If I know that this, basically I've got these two sitting over here. So I'm going to need to add those two angles together. So I'm going to go 26.57 plus 18.43. And what am I going to get? Let's look. 7, 18.43. Oh, I get 45 exactly. How nice. Now, just to point out, to get full marks, I should actually write exterior angle of triangle. And when I figured out this angle over here, I should have written angles on a straight line. So just remember to put your reasons in there. Okay, so I have done quite a nice tricky one there, which is from paper 2. What other topics, we've got about 10 minutes left for another question. What type of topics do you would you like to discuss from this part of the syllabus, or maybe something else? Just put in the chat, and if I see something that comes up enough, I'll make up a question for that. Okay, so yeah, for circle geometry, yeah, we're not going to jump to that right now. It'll be too hard to do in this. I mean more in functions, like in the functions, either functions in paper 1 or functions analytical geometry in paper 2. So what question, so either from analytical geo paper 2 or from functions paper 1, what is something that you would like as a question paper 1? Okay, how about analytical paper 2, functions paper 1. Okay, let me make up a function. F of x equals 3 to the x minus, 3 to the x minus 3. I want you to draw f for me. I want you to draw f for me. And I also want to know, what type of function is this? So tell me in the chat, what type of function is this? This is from paper 1. How would you draw it? So the thing that stands out for me is this is an exponential graph. Yep. And for an exponential graph, you need to kind of know the shape, and it's a positive value, so that's easy. You need to know what the y-intercept is, and you need to know what the x-intercept is. And you also need to know what the asymptotes equation is going to be, if there is one. And I think there is. So I want you to try and do that working out. I'll give you the asymptote because of limited time. The asymptote would be y is equal to -3. It's just going to be this bit here. But you still have to work out those two, and then you need to draw the graph for me. The sketch graph. Let me know in the chat what you think. So for this one, 3 to the 0 minus 3 is 1 minus 3, which is -2. And for the x-intercept, you need to solve that equation, which actually becomes that equation, and x would be 1. So your x-intercept would just be 1, 0, and your y-intercept would be 0, -2. Can you draw what this graph and what it looks like? Now, I know that there is an asymptote that it may not cross at y is -3. Do we know, when you've drawn your graph, just say done. So I know on the -2, which would be about there, and x is 1, would be about there. It cannot cross that line. Okay, that doesn't look the greatest, but that's functional enough. That is -2, and this is 1. And this is the function f. Okay, now some interpretation questions just to end things off. So for what, here's my first question, for what x is f of x greater than 0? So for what x is f of x greater than 0? What do we think our answer is going to be for that? So for which x values will the f of that x value be greater than 0? Where should we be looking? So we should be looking at the y-axis. And to me, it only is positive if it's above here. But for these x values, it's below. It's only from this x value across that it will get a positive y value. So all these ones will map. And so we need to have x greater than 1. Okay, question number 2. What is the range of f? So what is the range of the function f based on what you see on the drawing? So it can never go below y is equal to -3. So the range has to be y is greater than -3. Yes. Okay. Third question. What is the value of the f of 2? What is the value of f of 2? What is the value of the f of 2? What does the f of 2 even mean? It means, what is the value of the function when, if I put 2 in? Let's say 2 is here. I want to know, and I know that's not a perfect line, but what y value does that go to? Well, I've got the equation. So 3 to the power of 2 minus that is that, which is 6. So that must go with 6. Yeah. And let's see how much time. I've got time for one more. Okay. Okay, last one. You are given an equation, the g of x is equal to the f of x plus 3. I want to know what is the y-intercept of g. So you're given a new function, g of x, but it's all it is the f of x plus 3. I want to know what is the y-intercept of the function g that we've just, or g of x, that we've just created. Bonus points if you can tell me what the transformation is. So think about what the g of x, what is the equation of the g of x? It's just whatever I had before, which was that, but then you add 3. So the g of x is actually just the equation 3 to the x. How do you find the y-intercept of any function? You make x equal to 0. So what is the y-intercept of this function g that I've just created going to be? They sometimes like to do this at the end of function questions where they say, I'm going to give you a new function, but the new function is based on the old function, and we're just going to do something to it. In this case, I shifted it up by 3 units. It's actually a very quick way to do this. So actually, now that I think about it, instead of doing the algebra way, you could just go, well, here's the old one, 1, 2, 3, and you get to 1. Or you could say, what is 3 to the power of 0? It is 1. Give me a thumbs up if you understand why that has to be 1. Give me a thumbs down if you don't get what I was talking about there. That was the last question of the day.